Okay, so currently my hair is quite messy, but when isn't it? I don't think it's ever not been in any of it. But anyways, with that, we had some viewer questions, or a viewer question that I thought was worth answering. So today's video is not going to be a tutorial, and it's not really going to be a vlog post either. But instead, I'm going to kind of do a this versus that video, but not really. So we're going to start this video out talking about the history of virtualization, kind of as it pertains to us, but at least through my eyes, right? Like, where are the important stopping points to getting to Kubernetes? And then I'm going to end the video off with a short talk about how Proxmox and Kubernetes are not necessarily great complementing technologies, but how in the home lab they should be seen maybe together, depending on whether or not you're a developer or you're maybe an IT professional that's just looking for a way to run and experiment some of the other softwares that you're seeing and looking to play with and learn about. So with that, we're going to head over here to my laptop screen, and I'm going to start a PowerPoint presentation to talk about the timeline. So the question came in from AT Viewer, and this is the question itself. But to kind of summarize this question, he's saying that he doesn't fully understand Kubernetes, but he thinks that Proxmox and Kubernetes might be a great complementing technology to each other. And we're going to cover that, and we're going to cover basically my feelings on the answer to this at the end of this video. But I do think, depending on what you do, they should both be in your home lab. But I don't know if they greatly complement each other. And stay tuned to the end of the video to hear my answer on this. This first part of the video is going to be on the history of virtualization, starting all the way back in the 1960s, where there were basically mainframes at this time. Personal computers didn't really exist, and people worked on mainframes from a single console, but there was a need for multiple people to be able to access a mainframe from and have like separate user spaces. And one of the first systems to do this was the IBM CP67 here, shown in the picture with its user console. So and IBM was kind of the only player here. But this virtual machine, so to say, like this computer or mainframe that was divided up into different computers, virtual machines, was different than today's virtual machines. This was done at the hardware level before the operating system or anything even really came to play. Now, in the 1970s, a couple more competitors came to market, and both of these were also done at the hardware level. So now we move to the 1980s and the 1990s. More the 1990s, things stayed fairly stable through the 1980s, but in the 1990s, personal computers had really developed to the point that they were on orders of magnitude more powerful than the supercomputers or mainframe computers in the 1960s and 70s. And because of that, virtualization and the way virtualization was approached had changed. VMware was founded in 1998, and VMware was looking at virtualizing an operating system on top of an operating system. So there would be an operating system installed on the computer. That was what you interacted with every day. And then we would install more software on top of that would virtually create hardware for another operating system to be installed on top of. Now, this is basically the way it's done today. We do have some hardware interaction today, but basically this is how it's done, where we have an operating system and a virtualization software goes on top of it, and it emulates the hardware for the code to run on top of, and we have a whole entire another operating system that's managing that hardware and doing all of these tasks. So in 2003, QEMU was created, and the founder here pictured on the right, QEMU's ability was both to emulate user spaces and full-time platforms. So it's kind of the basis of we're starting to build containers here in a way, but containers are actually going to strip away that user space and only use the elements of that are needed. So they're different. They're quite different, actually. But we're able to divide up user spaces inside of an operating system now with QEMU, as well as emulate the hardware that the operating system goes on top of. So in 2007, KVM came out, and KVM, although it used a lot of QEMU's code, KVM took a giant leap forward with some of the virtualization technologies that were really entering the industry from both Intel and AMD at the time. And it allowed us to use hardware to actually break up the cores of the CPU and the memory, and then the interaction with the hardware and the software to create these virtual machines. And that gave us much better performance over virtual machines than some of the earlier VM and QEMU software. And it also allowed us to have a more bare metal-like feel and interaction in some ways with this software. It also allowed us to have like a Windows computer that is running a virtual machine for a Unix system and a Linux system and vice versa, and they can all kind of be compatible on top of one computer. So in 2008 is actually when Proxmox came out, and it should be noted that at this time Proxmox version 1 existed, and it did not contain support for LXC. So 2008 was also the year LXC came out, so this can kind of be confusing, but LXC wasn't baked into Proxmox until 2012. But LXC is the containerization technology that we still know today in Proxmox at version 7, which allows us to basically strip out all of the hardware control elements and work off the kernel of the Linux system or the Linux host operating system and just put our application layers on top of it. So how the user interacts with it and the programs, but still separate them from the main operating system itself. So we're just using the kernel's hardware management techniques to take and run the separate software. And that's what Docker and Kubernetes and some of these other containerization softwares really build upon today. But LXC is kind of notable here because it does still exist today in Proxmox, but it's really the first containerization software. So now we go out to 2013, and Docker's released. And we kind of talked about Docker already. So Docker is an engine. It sits on top of an operating system just like a game or another application would, and it virtualizes the hardware. Now, Docker in the early days, back in 2013, actually used LXC code to do this. They've since developed their own code for reliability and stability and use, but Docker aimed to build upon what LXC had created by standardizing a format for how images and containers are created, and building a script-like method for actually creating these images. This gave us a lot of ability to create images, create custom images easily, and allow them all to be standard so they could work from a Windows system to a Linux system to a Mac system and all kind of run. Now, we know from working with Docker runtimes, we still need to have different images depending on those operating systems, but they can really be packaged up, and as long as it's going to another Linux server today, they just work. You can deploy them and they work. So coming to the last slide of this tutorial, which is 2014, a year after Docker comes out, Kubernetes comes out. And Kubernetes was originally announced as a development project from Google, and then it turned into the Cloud Native Computing Foundation. And it really, Kubernetes, I really want to say is a lot of the basis of today, what we talk about with the cloud. But it goes all the way back to the 1960s, and it's really virtualization at its root. But what Kubernetes does is Kubernetes is a full-on management technique for these containered images that we've talked about with LXC and Docker. But Kubernetes also sits on top of an operating system like Debian, which is the host operating system of Proxmox, and they take and run these small application packages that but Kubernetes allows you to have load management and monitoring and things like that really look at how these images are up and running and their health of their images. So it's kind of like a data center. Well, it is a data center software, a cluster software that allows for management of Docker images. And now there's a couple other images out there, but Docker being the most popular and widespread known one. Now, Docker ultimately got written kind of out of the Kubernetes software and now has to be supported through a third-party project, but it still can be used, and it still is a great representation of how this containerization takes effect inside of Kubernetes. So now we're going to go over to another part of this video, and we're going to look at my feelings, and I'm going to talk about my feelings about how Kubernetes and Proxmox exist in a home lab together, because I think for a lot of professionals they should, but also why they're not necessarily complementing technologies and competing technologies, because they're both competing for a lot of that data center management world. And they exist in managing in a data center in kind of different forms of operation. And probably, I bet you, and I've never been inside of a data center, so this might not be true, but I bet you both of them probably exist or some form, maybe not Proxmox, maybe VMware's EXXI, but inside of some data centers together for companies that need to run things like VMs for whatever reason, whatever software that they're virtualizing to deploy. But Kubernetes is great for our cloud infrastructure where we want to push up lightweight containers that are kind of able to be deployed across multiple systems easily. If you've worked on a Proxmox cluster, you know that might not always be true, and we have to take a lot of pains to keep every system inside of our Proxmox clusters identical to make that happen. So with that, let's go over to the next part of this video. Okay, so I spent the better part of yesterday afternoon and this morning doing more research on the second part of this video here. And this is where I talk about, is Docker, or actually Proxmox and Kubernetes, complementing technologies that are running together on the same network, or are they really competing technologies? And I'd have to say, to cut it short, that Kubernetes and Proxmox are somewhat competing technologies. So Kubernetes is basically a way or a software solution for managing images similar to Docker images, but containers in general, that offers high availability, fault monitoring, load balancing, and basically high-level data center management tools all in a software package. Well, Proxmox is pretty much the same. Now, Proxmox is an operating system, and Proxmox uses what we learned about as older technologies, both VMs that date all the way back to the 1960s, and really the VM technology that Proxmox uses kind of starts to come into play in 1998 and doesn't really come about until a few years later in 2003 from QEMU. But it's still VM technology. It's older technology than Docker, which really hit the scene in 2013, along with LXC containers, which LXC containers really started to come in like the 2007 time frame, like we just learned. And although LXC and Docker, well, Docker's actually built on top, or was, it's no longer, built on top of LXC code. So they're very similar, but they're fairly different in the way they handle. Now, Proxmox, I like interacting with LXCs better. It feels more natural to me, and that's why I was so long before taking over Docker. But Docker has a lot to offer with their standardized way of building things and their repositories, how they kind of tie everything together. Now, Proxmox, if set up in a cluster and stuff, offers high availability and everything for their containers and VM. Now, Docker could be run inside of a container, and we have videos on doing that. And I'm sure most of you probably, if you're watching this video, have watched those. And that provides us backups and high availability failover and other things. Kubernetes, though, or I should say, that's only for the LXC container. If we were to run Docker inside of the Kubernetes or inside of the LXC container, then we wouldn't have that for the application. And if you were to do this with LXC, you'd have a lot of containers that were running, and for like load balancing and stuff that Proxmox doesn't offer, even in some of their cluster situations. Kubernetes, on the other hand, offers all of this, and it's built on top of an operating system you choose. Now, chances are you're probably going to choose Debian, but it could be built on top of Windows or even Unix if you wanted. I don't know why you would, but you could. Maybe Windows Server actually has a decent amount of presence in the industry. But yeah, so they're kind of compete in a lot of ways, where Kubernetes basically at its root containerization is basically Docker, and Docker engine could be used with Kubernetes. You have to install something called a CLI, and which is basically the container engine driver, basically. And you have to do a bunch of stuff to use Docker. Kubernetes tries to use some other containerization software, and I'm not full up on that yet. It was I kind of bailed out at that point because I started to realize I didn't have really the resources to set up a multiple system with the database and stuff, and that's when I found K3s and moved over to K3s because I could virtualize it on a single system and use the hardware I had here, and that was on the video that released at the time of filming yesterday. I don't know, think this will probably release tomorrow, so it'll be a couple of days old, but that was on the installing K3s video that was released. So with that, I'm going to kind of end this talk off because I'm going to kind of just ramble on about information, but my general thought process is that Kubernetes and Proxmox are somewhat competing technologies, but they do live well in a home lab together depending on your needs. So if you're doing a lot of web development, cloud development, and that type of software, like I'm looking on moving into, then as far as Kubernetes belongs in your house, you should know it, you should be designing for it, you should be testing on it, you should be doing that type of stuff. That's where it's going to live if you deploy it in most case scenarios. Now, if you set up a couple of DigitalOcean nodes and do that way, then you may choose not to do Kubernetes. I think I still would because of the load balancing and the fault tolerance and the scalability that it offers. It just makes things easier. AWS is in a lot of ways Kubernetes as well, just like it's Docker. It's got their own Amazon twist to it, but in a lot of ways, that's what it is. And we've also learned Google actually created Kubernetes, and Kubernetes at its heart is really Google Cloud Services. So just kind of something to think about there, right? Like you should probably be working with Kubernetes. But as far as your home lab stuff, like, your Pi-hole servers and your DNS servers and your hardware firewalls and all of that type of stuff that's necessarily going to give you your infrastructure, Proxmox is a great technology there. It allows you to pass a lot of hardware through. Not saying you can't do it with Docker. In some places, like GPUs, you can actually do it with Docker to multiple containers. Kubernetes, you can too. And that gives you a lot more advantages than Proxmox, where you can pass a GPU to a single VM, and that's that. So, and pfSense, you can pass over just you can actually pass over virtual, but you can also pass over just a single network adapter and keep it completely isolated from the Proxmox operating system. Probably suggested if it's an entryway firewall. If you're trying to segregate your network or create an area inside your home lab where you do your own stuff, well, then that might not be the best scenario, or the only scenario. But yeah, so I'm going to call them competing technologies, but I will say that they probably, depending on what you're doing in your home lab, both have a place there. But I would say that unless you have a pretty beefy Proxmox server, like not a little 4-core laptop with 5 gigs of RAM like I have down here, the South Carolina house, I would definitely say that it would probably require some extra hardware. I'm kind of excited definitely to get back to the Freedom House and look at some of like the Raspberry Pis that I got. I think I have 3 Raspberry Pi 4s. I know I had a request for doing a PyMox video that I'd like to do too, but then I think I'm going to set up a Kubernetes cluster, probably with Raspberry Pis, just to keep power low. Power's very expensive at the Freedom House versus down here in South Carolina. Anyways, with that, have a good night.